The allowable number of Romex wires per opening in a multi-gang electrical box, according to Underwriters Laboratories listing standards, is 10. This limit is critical for ensuring safe and compliant electrical installations. Exceeding this limit can lead to overheating, insulation damage, and potentially hazardous conditions. Several factors contribute to this limitation. Firstly, overcrowding wires within an electrical box restricts airflow, which is essential for dissipating heat generated by the current flow through the conductors. Romex, or non-metallic sheathed cable, consists of insulated conductors bundled together within a non-metallic jacket. This jacket provides mechanical protection and electrical insulation. However, it also contributes to the overall bulk of the wiring. Secondly, the physical space within an electrical box is limited by its dimensions. Multi-gang boxes, designed to accommodate multiple devices like switches or receptacles, have a larger volume compared to single-gang boxes. However, even in multi-gang configurations, the available space must be carefully managed to prevent overcrowding. Thirdly, the National Electrical Code, or NEC, provides guidelines for wire fill capacity in electrical boxes. While the NEC primarily focuses on the total number of conductors permitted in a box based on its volume, Underwriters Laboratories listings provide specific requirements for the number of wires allowed per opening. The NEC references Underwriters Laboratories standards as acceptable methods for electrical installations. This is to ensure that electrical installations are safe and reliable. Fourthly, each Romex cable contains multiple conductors, typically 2 or 3, plus a grounding conductor. The number of conductors within each cable must be considered when determining the total wire fill in the box. For example, a 14/2 Romex cable contains 2 current carrying conductors and a grounding conductor. A 12/3 Romex cable contains 3 current carrying conductors and a grounding conductor. The grounding conductor also counts as a conductor. Fifthly, Underwriters Laboratories, a globally recognized safety organization, tests and certifies electrical products to ensure they meet established safety standards. Underwriters Laboratories listings for multi-gang boxes specify the maximum number of Romex wires that can be safely installed per opening. This listing is based on rigorous testing and evaluation to verify that the box can adequately dissipate heat and maintain electrical insulation under normal operating conditions. Sixthly, proper wire management is crucial for achieving a safe and compliant electrical installation. Wires should be neatly organized and secured within the box to prevent them from becoming tangled or damaged. Using cable staples or clamps to secure the Romex cables as they enter the box helps to maintain a neat and organized wiring arrangement. Seventhly, when installing Romex wires in a multi-gang box, it is important to avoid kinking or bending the wires excessively. Sharp bends can damage the insulation and reduce the current carrying capacity of the conductors. The NEC specifies minimum bending radii for conductors to prevent insulation damage. Eighthly, the size of the Romex cable also affects the wire fill capacity. Larger gauge wires, such as 12 AWG or 10 AWG, occupy more space than smaller gauge wires, such as 14 AWG. Therefore, the maximum number of Romex wires allowed per opening may vary depending on the gauge of the wires. Ninthly, the type of connectors used to secure the Romex cables to the box also plays a role in wire fill capacity. Some connectors are bulkier than others and may reduce the available space within the box. Using connectors that are specifically designed for Romex cables can help to maximize wire fill capacity. Tenthly, when calculating wire fill, it is important to consider the volume of the box itself. The NEC provides guidelines for calculating the minimum box volume required based on the number and size of conductors, devices, and fittings installed in the box. This calculation ensures that the box has sufficient space to accommodate all of the wiring and devices without overcrowding. 11thly, exceeding the wire fill capacity of an electrical box can have serious consequences. Overheating can cause the insulation on the wires to melt or break down, leading to short circuits and electrical fires. Overcrowding can also make it difficult to properly terminate the wires, which can result in loose connections and arcing. 12thly, Electrical inspectors typically check wire fill during inspections to ensure compliance with the NEC and Underwriters Laboratories listings. Installations that do not meet these requirements may be rejected, and the homeowner or contractor may be required to make corrections. 13thly, to ensure compliance with Underwriters Laboratories listing requirements, it is important to consult the manufacturer's instructions for the specific multi-gang box being used. These instructions will provide information on the maximum number of Romex wires allowed per opening. 14thly, in addition to the number of wires, it is also important to consider the ampacity of the circuit. The ampacity of a circuit is the maximum amount of current that the circuit can safely carry. The size of the wires used in the circuit must be adequate to handle the ampacity. 15thly, the NEC provides tables that specify the allowable ampacity of different wire sizes based on their insulation type and installation conditions. It is important to consult these tables to ensure that the wires used in the circuit are properly sized for the load. 16thly, when installing Romex wires in a multi-gang box, it is important to avoid damaging the insulation on the wires. Nicks or cuts in the insulation can create weak spots that are susceptible to short circuits and electrical fires. 17thly, it is also important to ensure that all connections are made properly and securely. Loose connections can cause arcing, which can generate heat and ignite flammable materials. 18thly, the use of wire connectors, such as wire nuts or push-in connectors, is essential for making secure and reliable connections. These connectors are designed to provide a tight grip on the wires and prevent them from coming loose. 19thly, when using wire connectors, it is important to follow the manufacturer's instructions carefully. Over-tightening or under-tightening the connectors can compromise the integrity of the connection. 20thly, the proper grounding of electrical circuits is crucial for safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. 21stly, Romex cables typically contain a bare copper grounding conductor. This conductor must be properly connected to the grounding system in the electrical panel and to the metal enclosures of electrical devices. 22ndly, the grounding system should be tested periodically to ensure that it is functioning properly. A ground fault circuit interrupter, or GFCI, can provide additional protection against electrical shock. 23rdly, GFCI receptacles are designed to detect ground faults and trip the circuit if a fault is detected. GFCI protection is required in certain locations such as bathrooms, kitchens, and outdoor areas. 24thly, when working with electrical wiring, it is important to always follow safe work practices. This includes turning off the power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment. 25thly, it is also important to be aware of the potential hazards associated with electricity. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock and other injuries. 26thly, if you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. A qualified electrician has the knowledge and experience to safely and properly install and repair electrical wiring. 27thly, the Underwriters Laboratories listing requirements for Romex wire fill in multi-gang electrical boxes are designed to ensure the safety and reliability of electrical installations. By following these requirements, you can help to prevent electrical fires and other hazards. 28thly, remember that electrical codes and standards can vary depending on the location. Always consult with a qualified electrician or local building official to ensure that your electrical installations comply with all applicable codes and regulations. 29thly, failure to comply with electrical codes and standards can result in fines, penalties, and even legal action. It can also create a dangerous situation that puts yourself and others at risk. 30thly, always prioritize safety when working with electricity. If you're unsure about anything, seek professional help.